This video is about negative feedback amplifiers, in particular about inverting and non-inverting amplifiers. It corresponds to section 19.2 of Applied Analog Electronics, in particular to the second part of section 19.2. Alright, so what is it that we want to do here? Let's take a look at the block diagram for an amplifier. In the block diagram, if we're looking at a single signal coming in, a single signal coming out, both of these, if they're single wire signals, may be referenced to a common voltage Vref. So we'll have V in coming in, V out coming out, and the gain of this amplifier will be G, some number. The formula here is that V out minus Vref is equal to G times V in minus Vref. That's what we want as a block diagram for a single-ended amplifier, one that's just a voltage in and a voltage out, not a differential signal in or a differential signal out. Okay, how does that correspond, though, to the negative feedback amplifiers? Because I claimed I was going to be talking about negative feedback amplifiers. Well, let's look at the circuit for a negative feedback amplifier. We had an input coming in to the plus input of an op-amp. We had a pair of impedances hooked up to the negative input, and we had this one was ZI, this one was ZF. The outputs correspond. Now we have two inputs here to this negative feedback amplifier. We have two inputs over here, the main input Vn and this sort of constant side input Vref. Which one of these is Vn? Which one of these is Vref? Well, that depends on whether we want a positive or a negative gain here. If we put V in on the positive side here, then as V in goes up, V out will go up. That's what the plus here means, is that the output goes up as the input goes up. If we put V in on the lower line here, then as it goes up, this voltage drops, and V out goes down. So, and I just lied to you. This voltage doesn't actually drop. The input voltage here at the negative input of the amplifier, the negative feedback loop keeps that one clamped at the same voltage as on the positive input, because as long as V out is in the legal range, not hitting either of the two power rails, the huge gain of the op-amp means that the voltage difference between these two things must be tiny. So these two voltages are essentially always the same. That's an important trick for understanding op-amp circuits. Negative feedback holds the negative input to being essentially the same as the positive input. Okay. Back from that digression, let's take a look at what the gain would be for this amplifier. And we'll arbitrarily pick one of the two configurations. Let's say V in on top and Vref on the bottom. Now we'll need a formula for what the negative feedback amplifier does in terms of these two inputs, and we had that in a previous one. In fact, we had two different formulas, one of which pulled out the VM and one of which pulled out the VP. Let's use the one that pulled out the VM, so that we have V out equals VM plus. And then we had just VP minus VM. There was a minus V offset there. I'm just going to ignore the minus V offsets. If you need to worry about the offset, Any place where we had the VP, you can just subtract the offset from it, and it'll be the same as we had before. So I'm just going to ignore that for now. And that was divided by B. What was B? B was just ZI divided by ZI plus ZF. So the voltage divider gain. So we can rewrite this thing with VM now being Vref as just V out minus Vref is equal to V in minus Vref, and we're going to divide by B or multiply by 1 over B, so we're going to get that's 1 plus ZF over ZI. And again, if you have to worry about offset, that just gets added. See, I believe we're subtracting that from V in, so just subtract it off from V in if you have V offset here. That's the only place V in occurs. All right, this formula is the formula for a non-inverting amplifier. If ZF and ZI are resistors, then this is going to be a positive number. In fact, it's going to be a positive number bigger than 1. That's an important formula. It is worth memorizing. It's one of the few things in this class that's actually worth memorizing are the formulas for the non-inverting amplifier and the inverting amplifier. So what's the formula for the inverting amplifier? If it's worth memorizing, we better have it. All right, the circuit. The circuit is identical to the circuit for the non-inverting amplifier. So we have a positive and a negative input to our op-amp. We have a pair of feedback resistors or feedback impedances. There's no reason for them to necessarily be resistors. V out is V out. So everything looks exactly the same as before. There's only one negative feedback circuit. There's a tendency for some students to try to do positive feedback, of taking this feedback to the positive input. Don't do that. No positive feedback. It's always negative feedback. The only difference between an inverting and a non-inverting amplifier is how we label these two signals. The circuit is always the same. So for an inverting amplifier, we just put V in on this one and Vref on the positive input. So the V in is going into the negative side of this amplifier. That's the only difference between an inverting and a non-inverting amplifier, is which way you label these two signals. Of course, when we do the math for what's the gain, we want to use the other formula we had for V out, which was that V out was equal to, now we'll do the one where we pulled the VP out of the equation, VP plus, and let's see if I can get this one correct. It is Vref, or let's do it in terms of the things we already have, VP minus VM. And I'm again going to get rid of the V offset. You just include it with the VP if you need to. And this was going to be times, I believe it was 1 minus B over B. Okay. So far so good. What's 1 minus B over B? Well, 1 minus B over B, if we go back up here to what B was, that's going to be ZF over ZI plus ZF divided by ZI over ZI plus ZF. The ZI plus ZFs multiplied top and bottom by that, they cancel, and so this can also be written as VP plus VP minus VM times ZF over ZI. Now, VP and VM, those aren't the names we use on the outside here. Let's put in the correct names there. Get V out minus Vref equals, well, this would be Vref minus V in. So let's negate that so it looks like the form we want. Vin minus Vref, and then we've got to have minus Zf over Zi as our gain. And that is, again, the gain formula that's worth memorizing for an inverting amplifier. So, two formulas that are worth remembering. There's very few formulas in this course worth remembering. These are two. For a non-inverting amplifier, where the input is going to the positive input of the op-amp, V out minus Vref is Vin minus Vref times 1 plus Zf over Zi. And for an inverting amplifier, where Vref is going to the positive input and Vin is going to the negative input of the negative feedback amplifier, V out minus Vref is Vin minus Vref times minus Zf over Zi. Notice that this ratio here, if you're looking at just resistors, this ratio is always going to be negative. It can be from 0 to minus infinity depending on these things. If they're just looking at resistors, real values here, this is always going to be positive. And it's always going to be 1 or more. Because the smallest you can make this thing on the right here would be 1 plus 0. So the non-inverting amplifier has a gain from 1 up to infinity, and the inverting amplifier has a gain from 0 to minus infinity. And again, that minus infinity is dependent on what the open loop gain is of the op-amps, but effectively infinity. All right, so we have two formulas here. These are the two most important formulas to remember about negative feedback amplifiers. And they are definitely worth memorizing because you will be using them over and over and over again. These are not ones that you want to look up. They're ones you want to have at your fingertips. You want to be able to do this in your sleep. Gain of 1 plus Zf over Zi and gain of minus Zf over Zi. And you can remember whether they're positive or negative by where Vn is hooked up. Okay. Memorize them.